coloring in thingy-mabobby that we're starting our topic today, which is algebra. Specifically, what we're looking at in algebra is we're looking at expressions. Now you'll see there's a difference in algebra between expressions and equations. Right now, we're only focusing on expressions, and next term we'll start doing equations. So for now, I'm going to go ahead and get started. And what we want to do is I want us to go ahead and recap terminology. Now, I'm sure most of you would have started this at school already because exams are coming up and 100% you guys are getting tested on this. So let's do some exam revision for you guys. Can somebody tell me what is a term? What is a term? How will I know when something is a term? Yes, Itandile. I can't find you to unmute you, but you can unmute and talk.
Good afternoon, ma'am. Ma'am, we can find the meaning of a term by saying a term is a separation by placing or minusing a sum in an expression.
100%. So terms are separated. These are separated by either a plus or a minus sign. Okay, so that might be feeling a little bit abstract to some of you, but a term is in an expression. How do I know what a term is? Wherever I see addition or subtraction separating numbers, all of those numbers that are grouped together is called one term. And that will make more sense when we go and when we do examples. But for now, that's what we're going to think of terms as. It's separated by plus or minuses. And so what we can do to even expand this definition is, let me move this over super quickly. We can say it's a group of numbers. A group of numbers. And give me a second because I need to. I'm going to just put this here. I'm going to say it is a group of numbers and variables, because remember we're dealing with algebra, so there are going to be variables. So a term is a group of numbers and variables that are separated by plus or minus signs. And separated, what do I mean when I say separated? I mean separated from each other. Separated from each other. And we'll say by plus or minus signs. So what are terms? It's just a group of numbers and variables that are separated from each other by plus or minus signs. A variable, because I'm reading the chat. Why is saying a variable is separated by a plus, minus, times, or divide? Okay, so be careful with what terminology you use, because a variable means only x's and y's and variables, so letters. But it also includes numbers, just normal numbers, 6, 7, those are normal numbers. So it's numbers and variables separated, and by not times and divide, just by plus and minus. So if I have something like 2 times 8, this is one variable. Why? Because there's no plus or minus separating my 2 and my 8. So there has to be a plus or minus separating it. If it's multiplication, or even if we have division here, there's still no plus or minus. So that means all of this is going to be one term. So that is that. Liacho, we're just recapping some terminology that we need to know to do algebra. So far we've done terms. I'm just reading our answers in the chat. Itandile has said a constant is the value of where the value of the term is always the same. Yes. So yes, it's a constant is going to be a term. in which the value does not change. In other words, it's exactly what Thando has also said. Thando has said it does not have a variable. So a variable, we call it a variable because a variable is something that changes. So when something is a constant, it can't have a variable because a variable will cause it to change. And what do we know about a constant? A constant does not change in value. And so we can say a constant does not have a variable. And so what you should know is a constant is a term by itself, okay? A constant is a term by itself. And what is a term? It's a group of numbers and variables separated by plus or minus signs. So for a constant, what we'll know is it's going to be a term without any variables, okay? Then we look at coefficient. Itandile has also put in the chat, what is a coefficient? The coefficient is everything in the term that is multiplied, I'm assuming multiplied by the named base. Okay, so yes, it's kind of a confusing definition. You are not wrong, but what I'm going to write here is I'm just going to say, now remember, I'm not giving you guys textbook definitions. Immediately, we have started with a new topic, which is algebraic expressions. Right now, what we're looking at is we're just revising basics. So a coefficient is a number in front of a variable, okay? So if we know a number in front of a variable, that would be something like 2x. So in other words, what do we know? It is the number that is being multiplied to the chat is in the way of me writing here, to the variable. So now keep in mind, I don't want you guys to confuse your terminology. This is different to a constant. A constant is a term on its own that does not have a variable. A coefficient is when we have a term that has numbers and variables. So this 2x is one term. This whole thing is one term that consists of a number, which is 2, and a variable, which is x. What I'm saying is that my coefficient is going to be the number that is being multiplied to the variable in one term. So within this term, 2 is not a constant. 2 is what we call the coefficient. And I think you guys should know this from when we did exponents. Yes, when we did exponents, we spoke about what the coefficient was. And so you guys should be familiar with this term. And then when we talk about the degree, Umar has put it in the chat, and Itandile, the highest exponent of any variable in the expression. Beautifully said. Umar is also correct, the highest power. Tando, degree is an expression that is being raised by its exponent. So Tando, be careful, because yes, when we're talking about a degree, we are looking for the exponent, but we're looking for, in my entire expression, I am looking for the highest exponent. So here I'm looking for, when I talk about the degree, and we talk about the degree of an expression, the question will always be, what is the degree of the expression? The degree of the expression, and I feel like this is very cramped now, so the degree of the expression is going to be the highest exponent. The highest exponent contained in the entire expression. Okay? Now, these terms that we have spoken about now, this terminology that we've spoken about, these are all parts that make up an expression. So an expression has terms. Inside the terms, we could also have a term that is constant. So we have terms. We also have a type of term, which we call a constant. And then we also have a coefficient. A coefficient is within a term that has numbers and variables. We're looking for just that number that's being multiplied to the term. And then we're looking for the degree of the expression, where we'll look at the entire expression. So all of the terms in one expression, and from all the terms, what is the highest exponent? So I hope that we're all good and happy with this, these definitions and what we mean when we talk about this terminology. I just want to check in with Uma. I hope I'm not breaking up anymore, but Sando's given me a thumbs up. Thanks, Sando. You are even ahead of my question. Uma, I hope everything is okay on your side. If it persists, try leaving and joining in again. Sometimes it's just the internet connection. Imihle is still writing. Imihle, that's also what our screenshots are for. If you don't have time to take down all these notes, this is where a screenshot is the go-to solution for this. So if you want to take a screenshot, now is the time to do so, and you can finish up your notes later. Thank you for that, for confirming that with me, Liafo. Vicky, I'm gonna move on now. We have example 1. So this example is just going to go over the terminology to see, can we look at an expression and understand questions that are asked about an expression. So an expression is this whole thing. I've lost my pen. No, found it again. How do you take a screenshot? Well, if you're using a phone, I think everybody knows how to take a screenshot. If you're using a computer or a laptop, you can go Windows, press Windows at the same time as the print screen button, so that it will be it'll say PRTSC. And you can take a screenshot like that with a laptop or computer. If you have a MacBook, I'm sorry, I don't know how to help you. I do not know how to take a screenshot on a MacBook. Okay, moving on. When we look at an expression is this whole thing over here. So this entire thing is the expression. And now remember, my expression is made up of terms. Some of the terms can be constants. Some of my terms can have a coefficient. My whole expression will have a degree. So there will be a degree of the expression. And let us look at the questions and see if we know what how to answer these questions. So the first question asks us, how many terms? How many terms does this expression have? And Liafo has put something in the chat. Ma'am, the expression is 3. So terminology is so important. The expression is not 3. The expression is minus 2x squared plus 3x cubed plus 1/3. So your expression is not 3, but the amount of terms in the expression is 3. How many terms? There are 3 terms. Yes, Liaho.
Ma'am, I just made a mistake. Sorry, ma'am.
Okay, no stress. But I think it was a good mistake to make in any event, so that anybody else who was confused now understands. And so let me tell you guys why there are 3 terms. So remember, we're looking for things that are separated. We're looking for groups of numbers and variables that are separated by plus or minuses. So immediately I'm seeing a plus over here separating groups of stuff, and I'm seeing a plus over here, okay? Yes, there is a minus over here, but it's not really important to me right now. Why? Because it's not separating another group of numbers over here. So I'm not too concerned about the minus in the front. Three terms is called a trinomial. Does 1/3 count as a term? Yes, it 100% does. 4+ terms are polynomials. Yes. Also, ma'am, at school, my teacher told me if there's a fraction, it's a new term. Yes. Yes. So yeah, right now we have 3 terms. How did I get 3 terms? Well, how many groups of numbers are there that have been separated by these plus signs? This is my first group, second group, and third group. So 3 terms. I hope everybody is okay with that. What is the degree of the expression? Can somebody tell me that? Also 3. The degree of expression is 3. So thank you for that, Tando. How did we get 3? Because when I'm looking for the degree of my expression, I look at, and I say I'm answering Emitle's question, so Emitle, this explanation is for you. When I'm looking at my entire expression, when I look for the degree, remember what is the degree? The degree of an expression is the highest exponent contained in the entire expression. So we're looking at this entire expression. What is the biggest exponent I see? Well, the only exponents I actually see is 2 and 3. But from those 2 exponents, which one is the highest? The highest is 3. And so that is the degree of my expression. Then they're asking us, what is the coefficient of x squared? And I see you guys are giving me a lot of other terminology in the chat, which is great. You guys clearly know your stuff. So yes, you guys are so right now. Also, where the coefficient of x squared, remember what is the coefficient? It's the number in front of a variable. And here they're asking us, what's the coefficient of the variable x squared? So it's firstly very important that you pay attention to the exponent. Because if you were to look at this x cubed and then tell me the coefficient is 3, it would be wrong for this question specifically. Because this question wants to know what is the coefficient of x squared, not x cubed. So we pay attention to the variable that we pick, and then my coefficient is just the number in front of it. And so my answer there is -2, and all of you have put in the correct answer there, so thank you for that. Alia has given us the answer as well. And then it says, determine the value of this expression if x is equals to 2. Now, remember, these variables that we have, these are things that can change. So it could be x, or, x could be 2, or it could be 5, or it could be 7. For example, think of something in life that could change. Maybe, let's say, I'm trying to calculate my average, and my average depends, my total average, my term average depends on, maybe it depends on my mark that I get for English. Right now, I don't know the mark I'm going to get for English, but my mark could be 70, could be 60, could be 30. That mark could change depending on what happens. And so that's really what we have when we have a variable. We don't really know what the number exactly is going to be. It could change depending on a number of things. And so we use a variable. But right now they're saying in this specific scenario, what is the value of my expression going to be if x turns out to be 2? So what if we have a certain value for x, which is 2? How we do that is we go ahead and we substitute. So when they give us a certain value for x, what we have to do is we have to do what we call substitution. And I'm sure you guys are all familiar with this by now. And immediately, if you are confused on what is going on in the chat, ignore it for now. It is good terminology to know, but it's not important when you're starting out. So don't worry about it too much for now. Just focus on what's happening in the lesson. And so how do I do this substitution? Well, what I really want to do is I want to go and I want to take my expression, which is negative 2x squared plus 3x cubed plus 1/3. I want to go and I want to say, okay, well, now I know what x is going to be. X is going to be 2. So in this expression, wherever I see x, I'm going to replace it with 2. So negative 2, and here I'm going to substitute. Instead of writing x squared, I'm going to write 2 squared plus 3, and instead of x, I'm going to put in 2 cubed plus 1/3. Okay, and now, can you see, now I don't have any variables left in my expression. And the minute I don't have any variables left, I can multiply out and do my exponents and get an answer. And so that's what I'm going to do now. I'm going to say, well, let's deal with my exponents first. This is going to be negative 2. 2 squared is going to be 4 plus 3. 2 cubed. Can somebody tell me what is 2 cubed? Tando has told me 8. Tando has very fast fingers. Tando is always the first one putting the answer in the chat. But yes, you guys are all right. It is 8. And then plus 1/3. Now, another answer that I want from you guys, negative 2 times 4 is going to be what? Handle again for the win. Negative 8. Okay, and then 3 times 8 is going to give me 24 plus 1/3. Now, if you were confused how I got negative 8 over here, all I did was I was doing multiplication. I said negative 2 times 4. It's a negative times a positive, which gave me a negative. And then 2 times 4 was 8. And then now what I have to do is I can go ahead and say negative 8 plus 24. Somebody tell me what that is going to be. I have negative 8 plus 24. Kando is unbeaten. 16 plus 1/3, and I know this is just going to be 16 and 1/3. Okay, you could convert this. You could have done the whole addition of fractions thing. You could have converted 16 into a fraction with the denominator of 3 and done everything and then convert it back to a mixed number. But, you know, think about it. We have 16 cakes. I'm plussing 1/3 of a cake. What's my answer? It's going to be 16 and 1/3. So that is my answer over there. Bree, that's what you did. Now tell me, think about how long that took you versus if you just, you know, thought about it a little bit in terms of not maths rules that are going to take me forever, but still thinking about maths, but just a faster and more efficient way to do it. This way, I didn't have to do any of that times 3 divided by 3. No. Okay, so we skipped all of that. So up until this point, are we all good? Are we happy? I think let's change it. Let's do happy faces and sad faces. Bree, you've already given me a thumbs up. Let's do happy faces if you're happy, or sad face, or straight face if you don't know. Happy faces. Okay, there we go. Okay, lots of smileys. Okay, so that's that. Moving on. The next thing we're going to deal with is simplifying the following. Now, our brain break is coming up soon, Uma. So you don't have to stress. Now, if you don't understand what we're about to do not stress, because the 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 my brain is stuck. Give me a second, I'm loading. What was I saying? Oh, if you're confused, if you have no idea what's going on here, don't worry, because the next lesson we're going to do is going to deal with adding and subtracting like terms. But I think most of you guys will be used to the term like terms already. And so just to go here, what I want you guys to think about when we have these addition and subtraction when we're doing algebra. The first thing I want to tell you guys is, remember now, when we have variables and numbers, there are two things that could apply. We could apply our rule of like terms. I don't know what's happening to my handwriting. I'm so sorry. I am so sorry. Let's try that again. We can either apply like terms or we can apply exponent rules. Okay. Now, always what I see people doing is they say, ooh, 12x plus 7x. Well, that's going to be 12 plus 7 is 19, and x makes x squared. No, 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 no. Not correct. When I have plus or minus, I use my rules for like terms. The only time I'll start going x and x makes 1 plus 1 and then x squared, the only time I'll do that is when I'm doing multiplication and division. Think about when we did our exponents. The law said when we had the same bases multiplied by each other, the main thing there was multiplication. For law 2, it was division. So that is when I'll have exponent rules, and that's when all my exponents will start changing, and I'll start multiplying my coefficients and all of that. So keep your rules separate. How did we get to the 19x squared? I was telling you the wrong thing to do, Brie. That's not the right thing. That's what a lot of people do. A lot of people will see something like negative 12x plus 7x and say, okay, well, and then they'll even forget about the minus and they'll just say 12 plus 7 is 19 and x makes x squared. I'm saying that's wrong. Don't ever do that. It's wrong. That's not what we do. We always have to differentiate. Am I doing addition or subtraction? If so, I'm going to do my like terms rules, and I'll go through these like terms rules with you just now. If I have multiplication or division, that is when I start doing my exponent rules. And only when you have your exponent rules that you are applying is that's when your exponents will start changing. Okay? So I never want to see something like x plus x, and then all of a sudden you're telling me it's x squared. No, because this is addition. Do my exponent rules apply when I am doing addition? No. So I can't go and add my exponents. I can't change the exponent of my variable. So that's super, super important for everybody to remember and keep in mind. And yes, Itandile.
Ma'am, I have a question. Ma'am,
Yes.
can your answer ever end up negative? Then with like let's say negative 6x,
Mm-hmm.
it can always end up negative, or
For
is it?
like terms,
Yes, ma'am.
yes, it can end up negative. And I'll show you now when I go through those rules how it can end up negative.
Yes, ma'am.
Leila is saying, so it's the same. Leila, what is the same? When I said x plus x. Yes, so x plus x. Now, when we're doing addition, this is what I want you guys to think about. When we are doing addition, and this is like terms, these are the rules. This is how I have thought about it since I learned it when I was in grade 8, and it's how I still think about it to this day when I teach anybody. When I think about like terms, I think about a fruit bowl, okay? Now, I have a fruit bowl, and then there are apples. Okay, there are a bunch of apples. And then there are, and let me change this. And then there are bananas in here. And then there are also oranges in here. Okay. If I tell you, can you tell me what is in this fruit bowl? You're not gonna tell me there's 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait, what? 3, 6, 9. You're not gonna tell me there's 10 apples. Or you're not gonna tell me there's 10 bananas. And you're not gonna tell me there's 10 oranges. You're gonna go and you're gonna say, okay, well, there's oranges and oranges and oranges here. So that makes 3 oranges. And you're gonna see, okay, well, there's an apple, an apple, and an apple, and an apple, and an apple there. So that makes 5 apples. And then there's 2 bananas over there. So this is what you're going to tell me when I have the fruit bowl. You're going to say, well, there's 3 oranges, there's 5 apples, and there's 2 bananas. Okay? You're not going to mix them all together and say there's 10 apples, 10 bananas, 10 oranges. No. You tell me each one separately because I can't mix oranges with apples. I can't mix bananas and oranges. I want to know each one separately how many there are. Yes, Itandile. I think there's 2 hands up. Yes, Itandile.
Sorry, ma'am, I just picked up my hand by accident.
No stress, Imile, yes.
Hello, ma'am.
Hi.
So, ma'am, when we started with adding and subtracting like terms, my math teacher told me, like, if you have, for example, 5x plus 3x, it will be 8x. So the x won't change to an x squared because it's the same. It's the same
Yes.
variable. So it won't change to something different.
Yes, that's 100% correct.
Thank you, ma'am.
Pleasure. And so, Layla, okay, before I start again, let's see what Layla has to ask.
So, ma'am, when we simplify the numbers, do we just calculate till we can't calculate no more?
Yes.
Like,
Yes, that's
okay.
exactly what you do. You calculate until you only have a group of oranges and a group of apples and a group of bananas, and then you can't squish them together any more than that, right?
Okay, ma'am, thank you.
Pleasure. So let's look at this in practice. So over here, I'm seeing, okay, this is an X and this is an X. So I'm going to say this is an apple and this is an apple. It's the same thing. So how many apples do I have? Well, I have 2 apples. That's how we do like terms. And so let's look at it. I'm going to erase all of this and we're going to do this. Oh my gosh, erasing this forever. Okay, let's look at it here. So I'm seeing an X over here and I'm seeing an X. So wherever I see something that has the same variables, when I'm looking at whether something is the same, I'm looking at, does it have the same variables and does it have the same exponents? If it does, then I can say they're the same. Then I can add them. Okay, don't know what's happening in the chat. Okay, so let's go. And the way that I like to do it is when I find something that's the same, I do the same shape around them. So this is going to be negative 12x and positive 7x. And then the rest of them are just normal numbers. So I'm going to put squares around them. And then everything that has the same shape, I can add together. So let's add up my pink things. Well, I have minus 12 bananas and then I plus 7 bananas. Minus 12 plus 7 is what? Leila, I'm not sure what you're saying, but not the same. 7 and 12, but the C. I'm not really sure what it is you're saying there. But somebody tell me minus 12. If I have minus 12 and then I plus 7, what's my answer there? Yes, immediately.
The answer will be minus 5, ma'am.
Minus 5. And I have minus 5 what?
Minus 5x, ma'am.
Minus 5x. Think about it with the fruit bowl. You have 5 what? 5 bananas, 5 apples, or circles here because I was drawing shapes. Okay, so thank you for that, immediately. And I see people putting that in the chat. 7 and 12 are not the same or related in any way. Why are they included? Okay, they are included because remember when I said I'm looking for like terms? When I look for like terms, I only look at the variables and the variables exponents. I don't look at the coefficients. The coefficients can be different because remember, I can have 5 apples plus 3 apples. My coefficients, they are different. It's 5 apples, 5 and 3, but they're still apples. I'm still adding apples with apples. That is why I can add them together. Yes, okay. So I see what's going on in the chat. Let us also, guys, we are here to learn, and I know we all want a brain break, but we're here to learn. So if it so happens that we have to skip a brain break for a day, then we skip a brain break for a day. You guys will not die, I promise. And so yes, let's not talk about it in the chat. And I saw the question, ma'am, can we have a brain break? I saw it. I said, yes, we will. So let's leave it at that. And while I'm still teaching, let's please focus on the teaching that's going on and not argue with each other about it in the chat. So you can only add like terms because if you add unlike terms, the answer is wrong. Yes. And then, Leila, I hope that answers your question. Why I said 12x and 7x is the same thing. Because it's not about the numbers in front of it. It's only about the variables and the exponent. For example, if I'm adding 2 apples and I'm adding 6 apples, the fact of the matter is that my numbers here are different, but I'm still adding apples and apples. So that's how you think of it. And then let's add all my green squares. 24 minus 6 minus 5. Somebody tell me what's the answer there. $13. Oh my gosh, I didn't actually do this calculation myself. Yes, it is 13. And it is a positive 13 immediately. So thank you for that. So it's going to be positive 13. So that is that. Then if we look at the next one, I want a volunteer to maybe tell me what are like terms here, what are apples and what's bananas and what's pears. Any volunteers? Itandile, brave, so yes. Do you have a question or are you helping me?
You're helping them.
Okay, so I'm going to take purple for my first set of like terms. Can you tell me what are all the same here from this next one here?
12B
Mm-hmm.
and B.
And B. Okay, is that it?
Yes, ma'am.
Okay, next one.
Negative 3A
Mm-hmm.
and negative 2A.
Mm-hmm.
And
And
negative 6 and negative 2.
and then negative 6 and negative 2. So that is 100% correct. We have now circled all of our things in the same way that are like terms. So why is 12b and negative b like terms? Because they have the same variable and the same exponent, and the exponent here is 1. Okay? Why is negative 3a and negative 2a the same? Because they both have the variable of a with an exponent of 1. And so let's now go and add and subtract our like terms. We can only add and subtract like terms. So if these circles over here are my oranges, I'm going to say, well, I have 12 oranges, and then I'm minusing 1 orange. Wow. That is going to leave me with 11, and 11 what? 11 oranges. Okay. So Liacho, check your answer. Check what you added as a like term there. It is not 9b, it's 12b, and then we minusing 1b, which gives me 11b. And Leila, check that as well. I hope you guys understand that. And then we're dealing now with our squares. So let's just say those are our apples. Well, I have minus 3 apples, and then I minus another 2 apples. That leaves me with minus 5 apples. And hey, 4 apples, okay? And then we have minus 6 minus 2. Well, we should know that is minus 8. Okay. So Liacho, you were close, but be careful and see, how did I know minus 3 minus 2 gives me minus 5? Well, if this is 0, this is minus 1, minus 2, minus 3, minus 4, minus 5. How am I going to do this? Well, I'm going to start at minus 3. I started at minus 3, and then I needed to subtract another 2. Okay. To subtract on a number line, I go to the left. So I'm going to go once, twice to the left, and my answer was negative 5. And that is my final answer. Yes, Layla.
Ma'am, I have a question. In what order are we supposed to do this? Like, I'm at a order of like when we simplify. For example, I'm at 12b and negative b. How are we supposed to arrange it with the rest?
So it doesn't matter if you said, if your answer was like this, negative 5a plus 11b minus 8, it's still the same thing. Okay. So are you asking in terms of arranging it like that?
Yes, ma'am. Thank you.
Yes, it doesn't matter which way you arrange it, but generally what we do is we just go with the first variable we see in here is going to be the first variable we put down. And also when we're giving our answer for expressions, generally we like our constants. This is my constant. Remember, what is a constant? A constant is something that does not have a variable. So we like our constants to be at the end, and then we like the rest of our terms that have variables to be in front. I hope that makes sense.
Thank you, ma'am.
Pleasure. Okay, and then that's that. I will skip this next one and we will go into our brain break. Oh, I forgot I did this as the brain break. Okay, I don't think this is gonna take us very long. So you have to guess the phrase. Okay. So you're looking at the picture and you're guessing what the phrase is. And Shady was in there very quickly. It is misunderstood. So the word there is misunderstood, yes, because of the fraction. You know, we could say stood over miss, but that doesn't make sense. So it's misunderstood. Next one. Honestly, I didn't know what this was. I didn't know what this was. I had to like check the answer for this when I was putting it in. So I was like, what is this? It's not fishing. I mean, fishing, it has something to do with fishing, but it's not just fishing. Fishing hook. Shady is good at this. It is a fishing hook. Think about it because it's fishing in the shape of a hook. Fishing hook. Okay, next one. Get it. I did not expect you guys to get it so fast. But you are right. There's 4 get it's. So it's forget it. It's very literal. Like there are 4 get it's. So there's 4 get it. So the phrase is forget it. Yeah. This next one, I also didn't know. I couldn't figure this one out. Alia, wow. It is away. The word away is fading. So it is fade away. Yes, you guys are so fast. Honestly, you don't even take time to think. Next one. Yahu saying this is tough. Yahu, look at what the picture is saying. Like exactly look at what it's saying and think of the phrase it makes you think of. This is literally ice cubed.
Oh, okay, ma'am. Cool, ma'am. Yes, ma'am. I get it.
There you go. And so obviously some person would have been here like ice to the power of 3. Ice times ice times ice. But literally it's ice cubed. So we're dealing with ice cube. Yeah, they're too quick for me too, Lila. Then over here we have D movie. You guys, how are you getting it? 3D movie. I don't know if there's another one. I think this may be the last one that I'm about to go into. And I just know you guys are gonna get it in like 2 seconds. Oh. There we go. So it's not the last one. No idea. Ma'am, where do I get this brain break? I honestly can't remember. I prepped this so long ago. I just Google stuff, honestly. I just Google games to play. It is no idea. No idea. Liako got it. There we go. And now I think this is the last one. Teddy, I know. I didn't expect it. Honestly, maybe I'm just dumb. But like this took me some time. I had to like figure out what some of these were trying to tell me. You know? So I don't know. Maybe I'm just slow like that. Oh, there's another one. Oh, I think I knew. I knew you guys were gonna get it so quickly. Alia, there's no way. Alia is cheating. Alia is cheating. I didn't mean to. Robin Hood. Nobody else is putting the answer in. Yeah, it is Rob and Hood. It's Andile. No, I didn't mean to show you that. Why is it spelled like that? Because the word is actually hood, but then there's Rob in the word hood, which is where we get Robin Hood, because Rob is in hood. So Robin Hood, you know? And yes, you guys saw the next one. You guys saw the next one. Waterfall. Sorry, I didn't mean to scroll. Water that is falling. Yes, it is waterfall. Someone said water tap. I thought that was funny. Yeah, yeah. Water tap. Okay, that was that. That was our brain break. Oh, I need to sneeze. Okay, it's not happening. I just want to see. Yeah, I like that too. Did I? Yeah, no, I don't have the quiz podium. That is my bad. Is there a quiz today? No. So remember what I said? Well, if you weren't here in the beginning, you obviously wouldn't know, but Thursdays are quiz days. So on Thursday is when I'll give you a quiz. And then Tuesday is normally when I show like the results of the quiz. So I don't have the results here because I forgot. I forgot. That's my bad. Okay. I think we can do these next two before we go. So if we look at this, we have more algebra. This is also an expression. I want to ask you guys, somebody tell me how many terms is in A? If we're looking at A, how many terms are in this expression right now? Lufuno saying 2, Bree said, no, Lufuno said 4, Bree said 2, Liacho saying 4, Alia saying 4, Itandile is saying 3. Now, I want you guys all to see this is a trick question because you're looking at this and you're saying, okay, well, minus and minus, which means this must be maybe 1 term, 2 terms, 3 terms. So I think some of you maybe went and said, okay, this is 1 term, 2 terms, 3 terms, 4 terms. Or if you're saying 2, then you maybe went, no, if you're saying 3, then maybe you went 1, 2, 3 terms. But I see correct answers in the chat now. It's 1 term. Why is it 1 term? When I have something in brackets, the minuses and the pluses in there don't count as separation because it's all in the one bracket. So it's not separating the group of numbers. The brackets keep it in the group. So although, yes, there is the plus and there is the minus. Yes, Alia, when we're looking at terms, the plus and minus inside brackets is irrelevant. Shady, let's not judge. Let's not judge. That was a mistake I would have made also. Now that you look at it, it's actually 1 because my brackets, although there's minuses in here, my brackets serve as like a big rope, which is basically tying all of it together. And it's saying you guys wanted to be separated, but you're not going to be. So all of this is all grouped in this one rope, which is one thing. So that is 1 term. And -3 over here is not separated from my bracket by a plus or a minus. So this falls part of this 1 long term over there. Okay. And so because I wanted to explain that now, let's just finish up and multiply out here. So I think what you guys should know is you guys also should know your distribution rule. When you have something outside your bracket, you have to go and multiply it into everything inside the bracket. Itanile is asking if I can please give work. It's a little bit difficult for me to do that because I have everything in my notes, and then to put it on the classroom, I have to like convert it, and then it's very, very hard. I know you don't think it is, but trust me when I say that it is because of the formats that I have with the exponents and everything. So what I will do is I'll scroll through the things I haven't done and you can take screenshots. But just to close up, put for me in the chat, what is -3 times x? -3x, Tando, at the top of the chat always. Yes, you guys are saying -3x. Then, so that was that. We multiplied over here, -3x. Somebody tell me when I take -3 and multiply it by -y, what do I get? So I'm seeing you guys say -3 y, negative 3xy. No. So look at what we're doing, guys. We're taking negative 3 and we are multiplying it by negative y. Okay? Negative 3 multiplied by negative y. So it's a negative multiplied by a negative. And so immediately that gives me a positive. And 3 times y is 3y. There you go, Itandile, yes. And then last we have negative 3 multiplied by negative 2. What is that? Lufuno is saying negative 5. Lufuno, what you went and did is you did addition. Remember now, because we are distributing, when we distribute, we do multiplication. And so it's negative 3 times negative 2. If it was negative 3 plus negative 2, yes, your answer would be negative 5. Because I have multiplication in the center over here, it's a negative times a negative, which is going to give me a positive. And Lucille, yes, it is 6. And this is going to be 3 times 2, which is going to be 6. Now, Leila, I've been seeing you're making the same mistake with saying XY. So if you have a question about that or one clarification, just stay behind and I'll give you that if you want. But this is the answer for now. For those of us who are happy and understand this, thank you guys for joining the lesson and participating. We always love and appreciate that. And that brings us to the end of our lesson. If you have a question, please raise your hand. And I'll just say bye to everybody while I scroll down for anybody who wants to take a screenshot of the work we didn't do in the lesson. Bye.
Bye, ma'am.
Bye.
Boy. Bye, ma'am.
Bye.
Bye, ma'am.
Bye. That sounded like Itandile. Itandile, I still have stuff for you to screenshot. You guys should be very happy we didn't get to this question. Yes, Liaho?
Ma'am, can I take a screenshot quickly?
Yeah. Did you take of all of this?
No, ma'am. Let me just take a... Yeah, okay. Okay, I'm fine, ma'am. Thanks.
And then there's these other two if you want Liaho as well.
Okay, thanks, ma'am.
Pleasure. Bye.
Bye, ma'am.
I think it was Layla. Layla, I see you're still here, but your hand is not up. So do you understand? Oh, there we go. Yes.
Hello, ma'am. Can you please
Hi.
explain why am I wrong?
Okay. So I think what you were doing is, I think you were looking at this negative 3 and you were saying it's negative 3x. And then you were multiplying it by y. Is that what you were doing?
Yes, ma'am.
Now remember, my negative 3 is what's sitting outside my brackets. And when I use this distribution, when I have to do distribution, it's when I have something outside my brackets. And then to get rid of my brackets, what I have to do is I have to take my thing that's outside the brackets and multiply it to every single thing inside my brackets. Okay?
Oh.
So if we look at what's inside the brackets, there are actually 1, 2, 3 terms inside my brackets. There are 3 terms inside my brackets. And so I have to take my negative 3 and multiply it by each term inside the bracket. And I'm going to put my answer down here for each one of those sums that I do. So the first thing that we have to do is we have to say negative 3 multiplied by x. Can you see that?
Yes, ma'am, I see.
Then I also say negative 3. It's only negative 3 because that's what's outside my brackets. Then I have to say negative 3 multiplied by, And I also multiply it with the signs inside the brackets. So this is multiplied by negative y. And then I also have to say negative 3 multiplied by negative 2. And then I take the answers to all of these little sums I've got here, and then I put them as my answers over here that will form my new expression. Do you see that?
Thank you, ma'am.
Pleasure.